Welcome back to our Kubernetes series. In the previous chapter, we explored the architecture of a Kubernetes cluster, examining the control plane and node components. In this chapter, we'll shift our focus to Kubernetes objects, the fundamental building blocks that represent the desired state of your cluster. What are Kubernetes objects? Imagine you are building a complex application using containers, those lightweight, portable units of software. As your application grows, managing these containers can become a real headache. This is where Kubernetes comes in. Kubernetes objects are persistent entities that describe the desired state of your cluster. Think of them as blueprints, defining what applications should be running, their resource requirements, and how they should behave. By creating objects, you tell Kubernetes what you want your cluster to look like, and it works tirelessly to ensure that reality matches your vision. Kubernetes uses objects to represent the state of your cluster. Objects can describe what containerized applications are running and on which nodes, the resources available to those applications, the policies around how those applications behave, such as restart policies, upgrades, and fault tolerance. Key types of Kubernetes objects. Kubernetes provides a variety of object types to represent different aspects of your application and cluster. Some common examples include pods, the smallest deployable unit in Kubernetes, representing a single instance of a running container or a group of tightly coupled containers. For example, a pod would contain the container running your web server code. Pods are designed to be ephemeral, which means they can be created and destroyed pretty easily. Deployments, responsible for managing the rollout and scaling of your application by creating and managing pods. For example, if you define a deployment with a spec requesting 3 replicas of a pod, Kubernetes will create and maintain those 3 pods. Services act as an abstraction layer, providing a stable endpoint to access pods, enabling communication within the cluster and from the outside world. Services abstract away the underlying pods and provide a single point of access, even if those pods are created, destroyed, or moved around. Namespaces provide a way to logically divide your cluster into separate virtual clusters, allowing you to isolate resources and control access. How to define objects using YAML manifests. To create Kubernetes objects, you use YAML manifests, which are text files that describe the object's desired state. Think of them as recipes that Kubernetes follows to build your desired application setup. The manifest includes crucial information such as API version, specifies the version of the Kubernetes API to use. Kind, indicates the type of object you are creating, example, pod, deployment. Metadata provides identifying information about the object, such as its name and namespace. Spec defines the desired state of the object, including the container image to use, resource limits, and other configuration details. Object spec and status, understanding the desired versus current state. Every Kubernetes object has a spec and a status. The spec describes the desired state, while the status reflects the current state, as observed by the Kubernetes control plane. Kubernetes constantly works to reconcile the two, ensuring that the actual state matches the desired state. For example, if you set the deployment spec to specify that you want 3 replicas of the application to be running, the Kubernetes system reads the deployment spec and starts 3 instances of your desired application, updating the status to match your spec. How to work with objects. The power of the Kubernetes API. You interact with Kubernetes objects through the Kubernetes API, a powerful interface that allows you to manage your cluster programmatically. The kubectl command line tool provides a user-friendly way to interact with the API, allowing you to create, modify, delete, and inspect objects. Objects can be used with the following: labels and selectors, allow you to organize and group objects, enabling you to target specific objects for operations like scaling or deployments. Labels are like tags that you can apply to objects. Selectors let you group and manage objects based on those labels. Annotations provide a way to attach arbitrary non-identifying metadata to objects, useful for adding information for tools or scripts. Namespaces offer a logical grouping mechanism, allowing you to isolate resources and control access for different teams or projects. As you can see in the full example showing the label and selectors used in this example. Key takeaways. Let's recap the key points. Kubernetes objects are the fundamental building blocks of your cluster. They represent your desired state, and Kubernetes ensures the actual state matches it. There are various types of objects, each with a specific purpose. Pods, deployments, services, and namespaces are some of the most common. You define objects using YAML manifests. These manifests describe the desired state of the object. You interact with objects through the Kubernetes API. The kubectl command line tool provides a user-friendly way to do this. Don't forget to like this video, subscribe to the channel, and leave your comments or questions below. I'd love to hear from you. See you in the next chapter. Thanks.